Objective: problem solving involving resistivity. You are given a wire that is 2 meters long with a cross-sectional area of 1 square millimeter and a resistance of 16 ohms. Calculate the resistance of a wire made from the same material but now 4 meters long and with a cross-sectional area of 8 square millimeters. This question contains a lot of information. To make it easier to understand, let us first organize the data into a table. By doing this, we can clearly see which dimensions belong to which wire, making it easier to simplify the problem. We will organize the data for both wires separately. To further simplify our calculations, we will use algebraic symbols to represent each dimension. Now that the data is clearly structured, I will demonstrate two methods to solve this problem. The first method is easier to understand and preferred by most learners. The second method is faster but requires stronger mathematical skills. Let us begin with the first method. Recall the formula for the resistance of a conductor. Resistance equals resistivity multiplied by the length of the conductor divided by the cross-sectional area. Since both wires are made of the same material, they share the same resistivity, which we represent using the symbol ρ. Because wire 1 has only one unknown, we first calculate the resistivity using the given data. By applying the formula, we find the resistivity to be 8. Next, we substitute this value into the formula to calculate the resistance of wire 2. The resistance of wire 2 is found to be 4 ohms. Keep this result in mind for later. Now, let us proceed to the second method. We still organize the data in a table, but this time we look at the formula in a slightly different way. We observe that resistance is directly proportional to length and inversely proportional to cross-sectional area. In other words, if length changes by a certain factor, resistance will also change by that same factor. If the cross-sectional area changes by a certain factor, resistance will change by the reciprocal of that factor. First, let us analyze the change in length. The length increases from 2 meters to 4 meters, which means it doubles. Since resistance is directly proportional to length, resistance also doubles, increasing from 16 ohms to 32 ohms. Next, we analyze the change in cross-sectional area. The area increases from 1 square millimeter to 8 square millimeters, meaning it increases by a factor of 8. Since resistance is inversely proportional to area, resistance changes by a factor of 1 over 8. This reduces resistance from 32 ohms to 4 ohms. Finally, we consider resistivity. Since the material remains the same, resistivity does not change and has no effect on resistance. Thus, the resistance of wire 2 is 4 ohms. To conclude, both methods yield the same result. You can choose whichever method you find more comfortable.